Hello guys, welcome to another video. Today we'll be looking at how to build CLI application in Rust. In my previous episode, we looked at how to build a CLI application in Golang and the library called Cobra. So today we'll be looking at how to do a somewhat similar thing with the Rust. We'll be trying to build a similar application that we built with Go, which was a fake Git application, just to sort of give you a teaser or a sense of idea of how to accomplish things when it comes to building CLI applications in Rust. Now in Rust, in order for us to build the CLI application, we'll be utilizing a few libraries. I think a few libraries that are important for us to know, which somewhat are counterpart to the Cobra library in the Golang ecosystem. So the main first library that we should be aware about is a library called Clap, and this is basically a command line argument parser for us. It's a pretty good and feature-rich command line parser. It has a lot of similarities to Cobra in the sense that the kind of interfaces that you are able to build with this. The difference obviously is because this is Rust, we are able to actually utilize nice macros provided by the system to do things and to sort of almost declaratively define how our CLI arguments are going to be. And we can actually literally define our entire CLI arguments as a type in Rust, and that I think is pretty cool. So while you can use Clap directly, I think a slightly better library to directly use is a library called StructOpt, which is essentially it uses Clap with a custom derive, which is to say that you can actually define your type and then just use a derive syntax to indicate that this is the parser type for our command line arguments, and it also offers you a bunch of convenience methods to define different flags and command line arguments and types and things like that. And you can do everything you can with Cobra, you can do it with this as well. Before we go any further, I want to talk a little bit about Clap versus StructOpt. Since version 3.0.0, Clap now also ships with its own Clap derive, which seems to have similar goals as to what StructOpt offered. So for the time being, there is a little bit of a conflict or a divergence between Clap derive and StructOpt. They're obviously not completely feature compatible. There are certain differences, and as I understand, they are trying to resolve the differences and trying to bring the Clap derive idea under one hood. We would have to wait and see whether that happens or not, but hopefully that does happen. Now, as far as the code that we are going to build, I'm going to stick to StructOpt simply for the reason that I'm more familiar with StructOpt. But so I just wanted to let the viewers know that I am aware of the fact that we have Clap derive as well, which offers very similar, if not 100% compatible functionality as that of StructOpt. I would leave the choice of which library to use completely to you guys. Make your own decision. But I think it's important to be aware that these two exist, and hopefully the community, the open source community, is able to resolve their differences, and hopefully it will make our choice much easier in the future. But that's where we are at the moment. All right, let's get back to coding. Right now, for those people who might not have seen the previous video about building CLI applications with Golang using the library Cobra, I would recommend to please go and watch that. I will share the link to it in the description down below, so kindly check it out. I think it would be helpful to get a little bit more context, although I'll try to give context wherever necessary as much as possible. Alright, so without further ado, let's get started. So for the first order of business is we are going to create our fake Git application for Rust. The fake Git application for Golang looks something like this, and we'll do a similar application for us now. I'm going to call it fgitrs. We'll actually install the libraries that we need, the first one being StructOpt. Okay. So now that we've added StructOpt, now we can get started with building our interface. To recap a little bit, our fake Git application in Golang basically comprised of 3 commands that we supported. One was the init command, the other was the shell command, and then the other was the status command. The init command is the git init, which basically helps you initialize a repository, it into a repository. And then the status command, as you might be aware of, is the one that gives you the status on your Git's index, what things, what files have changed, what files have been added to the staging and things like that. And then we also added a nice little shell command, and what that did was essentially create a sort of a REPL which allows you to execute multiple commands continuously. And we'll try to replicate this in Rust. Also, for instance, init supported a flag called Q, which was like a quiet flag, and status command accepted like a path spec as an argument. So we'll try to see how we can do that in Rust. So the fact is, because we have these multiple commands that we are going to support at the top level, so instead of a struct, then what we will do is we will basically define an enum, because our command line arguments can be either one of either init, shell, or status, and so we'll define an enum instead of a struct. And I'm going to call it, let's say, fget. And the first command that we want to support is, let's say, the init command. The init command, like we said, has a quiet flag, so that will be quiet of type bool. What we'll do is we'll go ahead and add a bunch of documentation for this. Right, what you'll notice is we're able to utilize doc comments to define the actual statements that would be shown in the help of the application. I find this fairly convenient. I think it's a really nice thing. You of course can use a bunch of the methods that are provided by it to uniquely define the help messages. Right, so we will complain a little bit right now because we haven't declared this to be as a CLI argument, and so for this we'll support both short and long. So all we have to do is declare it this way, and once we do that, it already would recognize it as like we'd want. And let me also add quickly a little bit of documentation on this. Yeah, so this is going to be my documentation. So now once you define the type, what we can then do is we can actually get the options, the CLI options that are passed by simply doing a from args, and this basically gives you the type, passes the CLI arguments, and then automatically gives you. So this basically takes it from OS args. So the arguments that are passed on to your binary, they are consumed and then passed, and then it gives you the type for that. There are ways, and we'll utilize that when we're building the shell command. There are ways to actually parse just arbitrary strings into a command as well. We'll look at that later. So for the time being, what I'm going to do is I'm just going to basically display what was basically passed, so that it becomes easy for us to sort of inspect and look at what we're building. And let's just run this. And as you can see, it builds basically this help page for you. It consumes the documentation, the doc comments that we provided, utilizes them for the appropriate placeholders, and as you can see, there are a bunch of couple of default flags that are available for your binary, and there's also a help command that's added by default. Again, all of these things are very similar to how Cobra does it for you. It makes sense when you're building CLI interfaces that these things should be auto-generated, so that's that. However, the init command is the one that we have added, and as you can see, all we had to do is define a type. As you can see, actually here it's only showing us the first statement, which is considered sort of the summary of the command, and the longer one is not available here. What we can, however, do, for instance, is init-h again, and so here it gives us the detailed help for that. Also, you'll see that it does indicate the flag as well, the flag that we've defined, the quiet flag, and it picks up the documentation as well. So all we had to do was this. I think that's pretty cool. We're already completed the first command, so let's build the second one. I think I'll go to the status command for now. We'll build the status command to quickly refer how it implemented it in Golang. As you can see, status command accepted an optional path spec, and so we'll try to do that. Since it is optional, what we can simply say is wrap this value in an option, and this automatically is then considered as an optional. So let's look at the help. So when we just directly do the binary, you see the status has been added. If we look at the status as help, right now there's no documentation that we've added. However, it does indicate that we have path spec as an optional argument. The way we know it is optional is, for instance, you can actually just initiate you can just basically trigger the status command, and you'll see that now we are printing out the actual type that was passed from it. And since we've not provided a path spec happens to be none. If we did provide something, let's say this, that is then passed as as a string that we want path spec to be, and it's wrapped in an optional one. Let's quickly add the documentation for the status command. And now when we look at the binary at root, it shows you the summary. Look at status, and okay, let's look at the help for status, and now it shows the description as well. And the usage does indicate that the path spec is within square brackets, which is the convention to indicate that something is optional. So that's great. And since we've defined path spec as an option, since it's a type, it is obvious that that is the only value that can actually be passed. So for instance, if we were to pass more than one value to status, it automatically gives us an error and says we found one argument which wasn't expected, right? Because we expected to have only one argument, however we passed it another one other than the path spec. So it basically throws out an error by default. And there are also, I think, ways to override and change the wording of this messaging. So the other one thing that Cobra also does really well for you is give you a command called completions for you, which help you generate completions for your shells, such as bash, zsh, fish, and others. Clap or StructOpt doesn't do that natively by default. We'll have to write a little bit of boilerplate code to actually enable that. So let's do that. Now what we'll need essentially is we'll basically utilize clap libraries directly from within StructOpt, and we will be needing a few things from here. The main thing is the type shell, which represents what values it can hold, and then we'll add all these. We'll utilize this in actually our completion subcommand, right? So we will be adding as a completion subcommand, which would take a shell, which would be of type shell, and given this, based on whatever arguments we pass, we will try to write the code that allows us to generate the actual shell auto completion scripts. What we can do here, in fact, we can actually use StructOpt's method, and we'll look at some nice method here. We can actually provide, okay, what are the possible values that are accepted or acceptable for this command. And so we can say, okay, hey, let's say we add only bash and zsh. Let's say we only want to support that for now. And once you do that, let me add a little bit of documentation for this. Okay, so that's about it. So if you look at this, I mean, this doesn't actually generate them yet. However, this sufficiently adds the completion command. So, and you see completion is now added as a command. When we trigger completion, it actually indicates that it's an error because the value shell is required here. It's no longer an optional, so we have to say something. And then when you do provide, like for instance bash, it's now you see that it was passed accurately, and then the type that we get at the end of it is the completion, with the shell being the value of the shell being the type bash. Similarly, we can say zsh, but however, let's say if we did something else, we will see that it appropriately detects that as an error and say, okay, this is not an acceptable value or not a valid value, and then gives you an error. However, if we did want to, for instance, support fish, all we have to do is basically add fish here, and then it would again become supported because the actual native completion does support fish. I think it supports a bunch of others as well. So now that we have the command, let's also write a little bit of code of actually processing this command, which would allow us to actually spit out the completion auto completion scripts that you can inject in your shells. For the completion command, which would give us the shell, we will do something else. So what we'll do here is we will utilize clap function, and this gives us access to the clap app, which is something that the clap library basically does. It tries to build the clap app from the command line arguments, so we get directly access to that, and then we can use gen completions, or we can use gen completions too. Gen completions basically just generates them and outputs it to a file. However, I think what I want to do is output them to directly to std out. Yeah, I mean, again, it becomes a little more consistent with how we design or how Cobra deals with completions. It then spits them out to std out, and then if you wanted to save them to a file, you can obviously redirect the output to a file and you can achieve that. So let's do this. So yeah, so the create name macro is the one that I wanted to use. This basically is able to extract the name of the crate from your cargo terminal file and gives it to me, so that I don't have to hard code it. And it uses we can give it the shell as an argument, and then we have to provide basically std out to get the std out. We basically get it. So now when we look at the binary, it should look obviously the same, but we look at the completion command. It says this is required. Now when I say completion bash, what you'll notice is it actually generated the script for the auto completion for bash, and similarly you could do this for zsh and fish. Now let's move on to actually building the shell, which is basically like kind of like a REPL. And what I'm going to do for now is basically I'll be copying over the documentation. So as you can see, once the shell subcommand has been added, now let's actually build the shell. So for actually building the shell, what I'm going to do is we will utilize a library called Rust CLI. It's a pretty nice library. It's basically the readline implementation in the Rust language. And now what I'll do is we'll actually copy over most of this code. Yeah, but instead of doing it directly here, I think I'll probably create a separate function. So right now it's technically already designed to work. We basically get the line in this case. However, of course, there's these other error conditions, like for instance, if we happen to hit Control C or Control D, we want to handle them appropriately. And so that's for that. What we'll now do is basically, since we have the line which represents our command, we'll have to basically pass the command through, pass it into our command from string. Previously we were doing it from passing it from the OS args. Now we would have to pass it from string, and how we can achieve that is pretty straightforward actually. The first thing I want to do is we'll have to build the command itself, and that's because the command line parser requires it consumes also the binary's name itself as an input, right? Because typically that is also part of the argument thing. And so it requires that your actual command would be preceded by the binary name. And so we'll again use the crate name here to get the binary name, and then this would be followed by the actual line. This would represent our command. What we can do now is actually parse this command, and how we can do that is we can use a function called from it as safe. And so how we can do this is we can wrap the command here. So what we'll use is we'll split it by white space, and then we will simply use a mapper to map it to string type, and this should give us the actual command. And so either this goes through successfully, in which case we would have a command to work with, or this doesn't happen successfully, in which case we would have an error. And for the time being, in case we do have an error, all I'm going to do is just print out the error. So this is basically the passed command, and what we can then do is we can basically again just print this out. We have the shell command. Let's issue the shell command. It just outputs shell for the time being. And so what we're going to do is I'm going to call the REPL function here, starting the REPL. So as you can see, we're in the REPL. The way we're in a REPL is when we say help, it's able to give us this documentation. This is a line that I don't want printed. So let me just remove this. I control D out of that shell and we'll spawn a new shell. And again, when we say help, it gives us that these are the commands that we have. Let's try the init command. By default, this is how it works. We can say init-h, just like we did on the command line, or we can say init-help, or we can say help init. All of them work the way they were designed to, but as said, the difference is we're doing it directly inside this shell thing that we have in a REPL. So we can look at the status as well. Okay, it works. We can do this thing to look at the actual help of it. Now let's issue some random command which doesn't exist. You'll see that the command parser fails and spits out an error which we consume and actually show the user in our REPL. And so it says, found an argument ZC which wasn't accepted or isn't valid in this context. So it gives you a little bit of a help. Yeah, I think that covers it. Let's look at completion also, just in case. Just because what we do is we only parse it, we don't actually execute it. So if you see our REPL, once we have the parsed command, right now we're only printing it out. We're not doing anything with it. I think what I want to do is I want to extract this code out into its own function, something like process command, and then we'll call that process command here instead. Just ignore it in case we basically try to call REPL again. So once we have process command, what we're going to do is actually call process command instead. And here in our main, we'll also say process command for us. Let's run the binary again and let's look at the it works just as we expect. Let's issue the shell command, and this doesn't work the way we thought it would. We want the thing to actually run the REPL. We can actually intercept it directly here itself. If the line or nest shell. So if you say shell, and it says we're already within a shell and we exit and it works. However, if we did init or status, all the other things will not. I think this covers what I wanted to showcase. Hopefully, this helps you when you're building your CLI applications as well. I think that'll be all, guys. Thank you so much.